Good morning, Gophers. So before I start with my presentation, I need to find my mouse here. I want to say something about this special occasion. So in 2 days, on Sunday, it's Go's 10-year anniversary. And not in my wildest dreams, I would have guessed Go would become such an incredible success. And of course, none of this would have happened without all the contributors that helped move the project along over the years, and all the users that decided to give Go a try, and all the people that helped Go with adoption in various ways, such as organizing meetups, or conferences such as this one, or writing about it, or teaching it. And that includes all of you. I also have a confession to make. I'm really not that much into birthday parties. But I'm really proud to be part of this one and the Go community. So thank you, everybody. So let's talk about Go by the numbers. So the big picture is pretty impressive. Go went from a handful of in-house users in 2009 to an estimated 1.6 million Go developers in the world. And if we assume about 20 million developers worldwide, then that's a stunning 6 to 8% of all programmers. We estimate that more than 1,200 companies use Go one way or the other. And the number of Go contributors grew by 30% over the last year alone. But a graph showing contributor growth over the last 10 years is much more impressive than just a number. Thanks to all the contributors that helped making Go such a fantastic success story. And then we have the conferences dedicated exclusively to Go, 27 this year. That's basically one Go conference every 2 weeks on average. So we could be traveling all year long. Next year, there's going to be even more. And just as important as the Go conferences are all the Go meetups that have sprung into action all over the world. There's virtually no larger community or city that doesn't have its own local Go meetup. There's over 150 meetup groups with over 90,000 members. And now we also have the Go Developer Network, or GDN for short, created in March of this year. The GDN is a collection of user groups that work together with a shared mission to empower communities so they can build the next generation of Go software. And if you're part of a Go community, a Go user group that is not part yet of a GDN, I encourage you to learn more about it. And last, but not least, let's not forget the Go outreach groups, Go Bridge, and Women Who Go. Go Bridge is building bridges to traditionally underrepresented groups by using Go to teach them how to program. And Women Who Go focus on women and gender minorities. Both run separate scholarships for multiple Go conferences over the years and are crucial in helping diversification of our field. Let's look at a few more stats. Supporting some of the numbers I mentioned before, the 2019 Stack Overflow survey reports that 8.2% of all developers used Go. And among those developers, Go is the 9th most loved language. But this number needs to be taken with a bit of a grain of salt. In this list, WebAssembly is actually the number 5 most loved language. That seems a little strange. I mean, it's interesting technology, but I'm not convinced you want to program it in it directly. And Go is the 3rd most wanted language people want to learn, close behind JavaScript and Python. So no surprise there. But given our experience with Python programmers that eventually flock to Go, I think our future looks bright. And then the 2019 JetBrains developer survey paints an even rosier picture. Here, Go is the number 1 most promising language as of 2018, with same as in 2018, with over 18% of developers using Go in the past year. And what really sticks out to me here is that 41% are using Go modules already, which shows really great adoption. And last but not least, the 2019 HackerRank report says that more than 1/3 of all developers want to learn Go in 2019. That's the highest number among all languages. From 2017 to 2018, the number of Go developers who knew Go has increased by the number of developers in general who knew Go has increased by 40%, 45% according to this report, which is enormous. And this wouldn't be possible with all of you. So a big thank you to the Go community. Clearly, Go is up to something. Let's see what actual users are saying. Here's a testimony from Upbound. It's a company working on a Kubernetes native platform for managing software across multiple cloud services. I'll just let that stand here for a moment. And here's another one from Capital One, one of the top 10 largest US banks by assets. We're talking about large companies here using Go. So what sticks out here are a few key features. Simplicity, strong typing, concurrency primitives, garbage collection, fast compilation times, ease of use, and there's more. It's not always, and it was not always understood, in our industry anyways, that all these properties should be important in a language. So let's step back a bit in time. 2007 to be precise. 2007 was a big year in tech. It pretty much changed life as we knew it, for a lot of people anyways. Anybody know why? 2007? Yes? The iPhone was introduced, and that pretty much changed everything after that. But also in 2007, the software industry looked quite different than now. Even the Google logo was different at that time. At Google, C++ and Java ruled server programming, neither of them simple or easy to use. JavaScript was popular, of course, but rather slow compared to today. V8, Google's high-performance JavaScript implementation, was still in the making, and of course, there was no strong typing there. Python was popular and often used for plumbing by big systems together. Python was slow, and of course, there was no strong typing there either. And ML still stood for meta language and not machine learning. And while Rust was already underway, I believe it started in 2006, it was unknown to us. Apple's Swift, Facebook's Hack, and Kotlin were not around yet. But in 2007, none of the things we wanted, simplicity, fast compile times, ease of use, concurrency support, was available in many of the prevalent systems programming languages, at Google anyway. Yet we knew that some languages of the past had come up with solutions for these problems, but then somehow they got forgotten again. All this eventually led to this fateful Thursday in September 2007, when Rob Pike turned around to me and expressed his frustration about a 45-minute C++ compile, which really bugged him, and we spontaneously decided perhaps it's time to do something about this. Now, the details of this story have been told a few times, so I'm not going to repeat it, but it is interesting to look at how quickly we proceeded after that first-hour brainstorming session, which happened the next day on Friday in a meeting room called Yaoundé. So the following Sunday, just before midnight, I sent off a frantic email with everything that came to my mind in preparation for our next discussion, which we had planned on Monday. And this mail was really long. It already contained the idea for interfaces and methods as we know it in Go. It also contained detailed syntax for some more mundane things, such as the binary expression hierarchy. with only 5 levels as opposed to 14 as in C++ that nobody can remember, or suggestions for fixing C's switch statement. On Tuesday, Rob suggested the name Go, and it stuck. On Wednesday, Ken outlined his idea for top-level variable initialization, which is, of course, one of Go's features. Ken actually had been thinking about this for a long time, since the 1990s, in the context of Plan 9. After that first week, we pretty much already had a good idea of the general direction we wanted to go, so to speak. The forward push basically required stepwise refinement of each of these general ideas. We also had to negotiate some time, since some of us actually had day jobs as well. But on it went pretty quickly for a bit over 2 years, until the first public release. And here's a list of selected milestones leading up to that public release. We started working with the spec fairly soon. This was pretty important as a record of our design decisions. But also because often we would walk away from a brainstorming session with different impressions. It was not that uncommon that we'd decide upon a new feature and implementation details, and then Ken went off and would implement something slightly different. Sometimes something better. Or Rob and I had a different understanding of what we agreed upon. The spec was there where the buck stopped. Often that meant that we had to go back and change things, that we hadn't thought enough about all the possible corner cases or interactions with other language features. We were also basically in a startup mode. Decide upon the next step, implement, experiment, changes needed, rinse and repeat. We could have failed right away for a variety of reasons. Unclear goals, incompatible ideas, how to reach those goals, too complicated designs, no cooperation, egos, no manager support, you name it. Like an embryo after inception, either the cell division works or it fails fast. Somehow, though, we got lucky and we made it all the way to the birth stage when we open source Go with the first public release. And that could still have been the end of it. But as we know, the baby survived. We were, in fact, a bit overwhelmed by the public response. One does not open the internet fire hose without getting thoroughly drenched. And we were also slowed down. We now had a group of fans and some less friendly folks to pay attention to. Everybody who's had their first baby knows that effect. The first 3 days after birth are incredibly exhausting. Pretty much everything else comes to a grinding halt while the baby demands 200% attention. But maybe after 3 weeks or so, you get your bearings a bit, and with some luck and help, after 3 months, a new routine develops. When I looked at my personal notes of that week a few days ago, I noticed that my entry for the rest of the week was answering emails. But first, it was time for some champagne. So this was our launch team. I only owned like 6 champagne glasses at the time, I think. So that's why some of us had to do with paper cups. So how did we make it to the release? I think there's 2 things. Number one, we had a pretty clear goal. We wanted an alternative systems programming language to C++. And number 2, we had fairly concrete, solid ideas to start with and how to get there, as I tried to show with those first few emails. We also had sometimes quite different opinions, but we managed to compromise. And it's fair to say that we all won and lost various battles, more or less equally. And maybe the most important thing, nothing went in unless everybody agreed. And of course, the project wouldn't have gone anywhere without our manager at the time, Bill Corran, who really went along with our vision, who fully supported us, and without him, this wouldn't have gone anywhere. And of course, also, it wouldn't have gone anywhere without the know-how how to implement and design a programming language in the first place. So in summary, our approach was a form of design-driven development. But when we were not clear, we waited until a good design presented itself, as they sometimes do during a morning shower, or on a drive home, or sometimes in a discussion with somebody else outside the team. Some of the best ideas actually came from outside. And we said no to almost everything because, after all, most ideas are usually not great ideas. Still, we made pretty good progress due to being a small team with virtually no users except us. After the release, we went back to work. Go was still a new idea, and like newborn babies, new ideas are fragile. We gave a lot of talks, most of us, but especially Rob Pike, Russ Cox, and Andrew Durand, to explain the thinking behind the language. We also kept tweaking the language and library, but really mostly the library. I've taken a look at the language changes between the original open source release and Go 1. There are perhaps a dozen or so that stick out, and here is a selection of 10. Most of them were backward compatible refinements, such as the first change here, which allowed us to have an optional second expression in a slice expression. But 3 changes really had the most significant impact. The new semicolon rules, which made semicolons optional, went into effect 1 month after the release. And almost a year later, notice that long time span, the addition of the append built-in was added, which made dealing with slices much easier. And another year later, just before Go 1, the introduction of the built-in error type, which replaced os.error. This very first change required a bit of automatic rewriting, which GoFont was doing. And also, we didn't have that many users at that time, so that was not that bad. The second one was just an addition of a language feature, so nobody was affected by that unless you wanted to use it. And the last one was done by a tool called GoFix, which we used quite often in the beginning to make automatic pervasive changes across the standard library. So again, note the slow, very careful pace of these changes. And as before the release, we actually continued with almost the same approach as before, if at a slower pace, since we had our first external users. And most of these changes on the path towards Go 1 were in the standard library, and notably, most of them were deletions, actually, especially shortly before Go 1. We deleted a lot of code. Also, now that we were open source, the semicolon and append change actually were the first changes that came with a detailed proposal that we had sent out in email. In March 2012, we announced Go 1. It's worthwhile pointing out the main motivation for it. Stability for its users on a time scale of years. It's really important to let that sink in for a bit. Stability for its users on a time scale of years. Another way of looking at this is that the Go baby had grown into a toddler of about 2.5 years. Go was still wobbly in parts, but now the toddler could walk and talk and generally had its own distinct character. So the effect of that Go 1 compatibility guarantee became apparent quickly, as all of a sudden, a lot of companies started betting on Go more seriously. Go 1 was absolutely crucial for the uptake of Go. A few years later, the Go effect was also clearly visible in searches for the term Golang, which started rising steadily after a somewhat flat period in the beginning, after that initial spike in 2009 when we released the language. So since 2012 to now, we are now operating under the Go 1 compatibility guarantee. That means the standard library even cannot change unless we change it in a backward compatible way. Same for the language. And the standard library actually contains a tool, the API checker, that makes sure we don't make any changes by mistake. As a result, work after Go 1 was much more restricted. It was still possible to make minor language changes, but we eventually stopped doing them altogether because we didn't have a concrete plan. Most work does was getting into better runtime, better compiler, faster, better tuned libraries, better tools. Or going back to our human analogy, our Go toddler was now growing up to become a pretty big kid around the block. He got stronger, faster, learned a few new tricks, and he'd acquired a lot more new friends. But his general character did not change that much. We also started focusing more on our community. This was probably an area which we had neglected a bit at first and where we had made some mistakes. We couldn't proceed with our local internal decision-making alone anymore. There were just too many stakeholders. Our toddler now played with lots of other kids, and we wanted everybody to play along, fair and nice. So equally important as the system improvements, especially in the long run, were the introduction of the code of conduct and the proposal process. They put in place a framework for the community to participate in the project. On this subject, I highly recommend, if you haven't seen it yet, Andrew Geran's fantastic closing keynote at GopherCon 2015, where he talks about these two things in particular. In the following, I'd like to focus a little bit on the proposal process, which is sometimes misunderstood. It is important because this is really the primary mechanism for influencing the direction of the Go project. It also is deliberately simple with only 4 steps, and most of the time only 2 steps. The process very much mimics the original design-driven approach, except that it's slightly formal because we can't just put everybody into a room and hash things out. The proposer starts usually with a brief GitHub issue. The emphasis here is on brief. It's overwhelming the proposal reviewers with a lot of text. It's just not going to sway them one way or the other. Then there should be a discussion on the GitHub issue, which aims to triage the issue. There are usually 3 outcomes. We accept it, it's being declined, or maybe we need more information. And in that case, we may require a design doc. That should be rarely needed, but for language changes, we probably want one. And if necessary, the proposer creates that design doc, possibly with help from other users, and maybe with help from the Go team. And eventually, there is a final decision, a discussion. And then the Go team decides that outcome. The first 2 proposals I mentioned before were the semicolon and the append proposal, and they were done via email thread. The Go team did all of the steps, but we notified the community via email. And in both cases, they were well received, so we moved ahead. So what makes a good proposal? I've written a blog post a while back, Go 2, here we come, where we have outlined minimal proposal selection criteria for Go 2 proposals, which are often language changes. But those criteria largely apply to regular non-Go 2 proposals as well. It's worth having a look at them here. First of all, a proposal should address an important issue for many people. If only a few people are affected, the cost of implementing the proposal is simply too high. Even very, very tiny changes, such as introducing binary number literals, as we did last year, actually was much more expensive than we expected. A proposal should also have minimal impact on everybody else who is not affected by the issue. And finally, it needs to have a clear solution. If the solution is unclear or not well understood, it's probably better to err on the side of caution and wait. If none of these minimum criteria are satisfied, the proposal has very small chance of even being considered. So initially, proposals started to simply pile up. Nobody really took care of them. In order to make progress, a while back, we introduced proposal reviews, where on a weekly basis, senior Go team members sit together for about an hour and review the latest proposals or shepherd older proposals along. It's not a glorious job, sorry. It's just to make that clear. More recently, we also have started publishing meeting minutes to make the process more open. Here's an example of those minutes from a meeting in last September. Basically, we write down what issues and proposals we looked at, what we discussed, if we said something, and what we decided about them. We also have a category we call go-to proposals. They are discussed in a separate proposal committee. Go-to proposals are the same as regular proposals, but either break the Go1 compatibility guarantee or are a language change. So they require Go2, the next version of the language. We started making small language changes again, starting with Go 1.13. And this process is really the same as it was before Go was open source, except now that everybody has input on the next problem to address, and everybody is involved in the discussion. But at the end of the day, it's still the Go team that makes that final decision. And I'll get back to that in a little bit. And like before, chances are we will say no to almost everything. Let's keep in mind those 2 million Go developers who don't want to change their code if they don't need to. So recently, we have seen a proliferation of Go-to language proposals, maybe as a result of opening the gates to language changes, or maybe as a consequence of our own final try proposal that failed and inspired alternatives. But being open to Go-to language changes doesn't mean it's open season for everybody's personal pet peeve. Some of the most recent language proposals I have seen contained what I would call red flags. Here's a list of examples. We've seen proposals featuring each of these patterns, and such proposals generally won't go very far. So you want to make a language change, a syntactic change. Rob Pike said, I think it was 2014, the language is basically done. If you want to change the syntax because you don't like it, we will have to say no. We do have identified 1 or 2 major areas of work. Better error handling and generics, but everything else is mostly off the table unless it is a generalization of existing patterns or fine-tuning the language in some way. So we'll still keep doing that. Sometimes people come in with an idea that they bring in from a different language. But chances are that what you want to do, you can already do in Go in a different way. So I asked those people, please spend some time with Go first before suggesting the need that it needs to be changed. The third one we see a lot. Unfortunately, it just cannot be the Go team's job to figure out what's wrong with your proposal or help shepherd it along. It takes too much time, it doesn't scale. And sometimes people say, I want this is useful. Turns out a lot of things are useful. That doesn't mean they fit the bar for inclusion. And the last one is not really stating a proposal, it's stating a problem. Maybe there's an issue, could well be, so we should file an issue. But without anything that is actionable, we cannot move forward. So proposals, especially language change proposals, they need to address a widely recognized issue. They need to affect a lot of people, have pretty clear solution, ideally should be backward compatible, and they should not impact people who are not affected by the issue otherwise. So why are we setting this bar so high? Even with Go 2, we want stability for our users in the order of years. Languages that have been successful in the past, such as C, C++, Java, and others, they followed exactly the same mantra. So this focus on backward compatibility is paying dividends. When we look at searches for Golang from 2012 to 2019, as a measure of popularity for Go, we see the same continuation of the curve we saw before. In fact, to me, it looks like an exponential growth curve for now. It's fun what you can do with stats. So, in summary, backward compatibility is really painful for language designers and library designers, but it's magical for end users. And we really should keep that magic. So, where are we going from here? There are some shorter-term goals that have been communicated before. We are working towards Go 2. Module support will get better and better, and once modules are used by the vast majority of Go users, they will not only help the general ecosystem, but they will also make it possible to gently break language backward compatibility if we desire to do so, because modules can specify a specific language version. For instance, since Go 1.13, the compiler accepts a new -lang option to specify which language version we want. Together with modules, in the future we will be able to say that a package requires a specific language version, say 1.13, because it makes use of binary number literals, which were not available before that. We may also be able to break up the standard library and have more fine-grained releases of some packages, or maybe make API changes that are long overdue and that we couldn't do because we had to be backward compatible. But of course, the compiler will need to continue to support old versions for the foreseeable future. And we will push forward with our generics design to the point where we have a concrete proposal and a prototype to play with. And we're probably going to do the occasional well-received minor language change to fine-tune it for common use cases. So I mentioned earlier that the Go team will continue to make the judgment calls in proposals, at least for the foreseeable future. And that may, of course, change at some point. We simply don't know what the Go team looks like in 5 or in 10 years. But until now, steering by the Go team has worked pretty well. The primary goal really here is to keep Go true to its original vision. Closely related to that is what Russ Cox calls doing less, enable more. The Go team didn't and can't possibly scale with the growth of Go, at least not how it's going right now. In absolute terms, we may contribute even more than ever, but in relative terms, compared to the efforts of all Gophers in the world, the Go team's engineering output is necessarily shrinking. We simply don't scale the same way. Instead, the Go team efforts will need to focus on strategic aspects. For now, on the language side, that's generics. And on the infrastructure side, that is module support. So Go is 10 years old now, or 12 if you actually count from the start of the project. So if we use our human analogy again, Go is about to become a teenager. We all know what that means. Teenagers want to develop their independence. They still need their parents, but much less so. They may do stupid things. They may start hanging out with the wrong crowd. They may get into drugs. So the best advice usually given to parents is to hang in there, listen a lot, provide lots of love and attention when needed, but also to permit the freedom teenagers crave. Do less, enable more, as Russ would say. Luckily, I believe our teenagers' core character, the language proper, and many of the libraries, is pretty solid and not easily compromised. And should the time come for a major life decision, such as whether to marry Go with generics, I think we'll be well prepared. So with that, on to the next years, and happy birthday. Thank you.
Wow, thank you, Robert. We don't normally do Q&A, but since we have Robert here, he's agreed to do a few questions for us before the break. So does anybody have a question for Robert? Raise your hand. No one has a question for Robert Griesemer, really?
Yeah, and I also have these special limited edition stickers. So.
There we go, right over there.
In your review board, were there any decisions that you really agonized over or had a lot of kind of group disagreement?
Were there any decisions that the question is there any decisions that they really agonized over as a group?
Yeah.
Kind of, what was the most hotly contested kind of issues you've
So are you talking
over?
about decisions in the early parts of the project or anytime?
Anytime.
There are lots of decisions that we agonized over.
What was the one thing, let me kind of, what was the one thing you fought most for that didn't get in?
Okay.
How's that? Is that like a, yeah, there you go.
Well, there's a couple. Interfaces is probably one where we had quite different ideas. I felt very strongly from early on that interface needed to be very, very simple and that they should basically contain a set of methods. Not everybody in the team agreed. Some people thought there should be ways to add fields to interfaces somehow or default methods and things like that. But I think that would have made it more complicated to use them and it would have made them harder to combine the way we combine them now. And it turns out that all the things that you could do with those mechanisms you can do anyway, so why add those features? Another one was how we handle exports. In the early days of the language, if you wanted to export something, you would have to write the export keyword in front of it. So you'd say, variable x, something, and then if it was a struct, you would say export struct, something along those ways. But that was really...
I'm glad you didn't do that.
Yeah. That was really cumbersome because then, would you have to write export in front of each field? And some of us felt like, yeah, that's fine. And I felt like, no, we don't want to really export each field by default. I want to not export fields by default. And so we were agonizing about this decision for a long time because it was not clear how would we mark those identifiers for export. In other language where I came from, Oberon, the export was done with an asterisk. So there was an asterisk after an identifier, and that would mean this identifier is exported. But in Go, that's not such a great solution because asterisk means other things.
Yeah, but think of how cool our code would look if it was like asterisk foo asterisk.
What was that?
Think of how cool the code would look if it was asterisk foo asterisk.
So anyway, but then we got this idea, which actually came from somebody else outside the team. Why don't we use capitalization? And at first that was a little bit of a shock, but then we thought, wow, this is really cool. And
it's an incredibly simple idea.
Yes,
and it's
so
brilliant.
Now we think it's one of the best ideas, and this is definitely an idea that came from outside.
Yeah, I love that idea because I can look at any piece of Go source code and immediately tell.
Right.
Immediately. I don't have to look for identifiers. It's amazing. Okay, another question. We have another question for Robert right down here in front. Sorry, Van, you can't sit down during Q&A. You got to be running around.
Hello. This is a little silly, but on one of those slides, you had a comment about one of the changes that came in before Go 1, and it said something along the lines of like 9 is prime / only.
Oh yeah, I was also wondering
like
about that. Only on a hot day, 9
Yeah.
is prime.
Yeah, I forgot about that. Though.
It was a weird little thing. You just skipped right over it. It was one of the most interesting things there.
Yeah, there's. We did.
There we go. Yep, right there.
That's it. Yeah, we actually. Yeah, we actually did. In February 2012, we made a contribution to number theory, but it was completely ignored. So I encourage you to.
Did it only affect the number prime? The number 9?
Yeah.
Okay. So it's like a Beatles
Here are the two
reference.
change lists that you can look up. So.
Interesting. Okay. I think we got time for maybe one more question. One more question for Robert, right down here.
In the early days, when you made the decision not to deal with dependencies and leave that for later, how that discussion go forward?
Can you repeat the question one more time?
So, dependency management was not dealt with right away, right? It's been, well, we just got Go modules last year. So how did it go for the first 10 years, like about dependency management?
Well, so this was clearly an area where we made a mistake. Okay. We simply did not understand the issue. And our original, first of all, we didn't have that kind of problem inside Google. And many of us in the Go project didn't really have much experience with the kind of dependency management that maybe people dealt with in other companies. And so our original answer for a long time was, well, do vendoring. You are responsible for the code that you're shipping eventually. You should really be in control of all the code that goes in there. And that's really still true, but the solution was not great. And people were complaining, lots of people were complaining, and alternative tools appeared. And eventually we decided, especially Russ Cox, who then really looked into this problem, that we really need to address this problem. And our solution now is Go modules, which I feel like is a great solution. It's a very efficient solution, and it does take care of this problem to a large extent. But as I said in the beginning, it's a much bigger problem. Even with Go modules, you're still responsible for all that code that you're depending on. And there's all kinds of issues that we're only starting to begin to address, such as security. Just because the code is open source and you can look at it doesn't mean that everybody actually looked at it. And there are examples in the recent past where malicious code got snuck in via open source and nobody noticed. So there's still lots of problems to answer and address there.
Yeah, that's a tough nut to crack. So I think it was a great talk, and I really appreciate that. And one of the things I loved about that was if you just, not even this screen, but there was another screen if you looked earlier, and it said 10 years ago, Ian sent the very first email about generics. And we still don't have them yet. And that's actually, I think, a positive thing, because what that shows is that the Go team does care, and they're not just going to implement whatever they think is right. They're going to take their time, and we've seen that. I've been in the community for 6 years now, and I've seen that repeatedly, and that's always great to see. And it's nice to have someone like Robert come and just kind of explain that to us a little bit more. So thank you very much, Robert. I appreciate it. We're going to take a little break till 10:45 and come back in here. We're going to have some more great talks. Robert's going to be around. I'm sure you can ask him some more questions. So we'll see you at 10:45.
Thank you.